Okay, so today is the 17th. We're going to start our warm up. You should have already kind of started your warm up. We're going to finish the notes on scatterplot. We're going to try to finish the notes on scatterplot. Okay. It's the first step, baby. The first. No, the first step.
Oh.
Okay. If we finish, then we can do some guided practice with it, some things in the calculator. If we don't get to this part, it's okay. Okay, we have next week that we can work on it. Tomorrow we're going to have a quiz. It's going to be very basic on scatter plots. Very, very basic. Positive correlation, negative correlation, those things that we talked about on yesterday, and the things that I'm going to drill into you today. Okay? Or attempt to. There is no homework help video because remember, at this point, you should already know you have 3 homework help videos this week that you can refer back to help you with Thursday's homework. If you haven't completed the already, you need to make sure that you complete the already. The already project is due tomorrow. Okay. All right. So please write that down. I'm going to pause for the calls. Make sure you have it written. All right. Okay, we're on week 4. We're writing down Thursday's assignment. This is the 17th. Please make sure that you check off if you did your homework last night. Please check that off. If you finished the graphing stories project, check that off. Okay. Remember, your stuff is in pencil, the other class is in blue. All right, so we got Math 8 homework tonight. There is no homework help video. You need to make sure that you finish your 3 lessons in already. Okay. And don't forget that if you haven't finished the graphing stories project, that you finish the graphing stories project. We finished it in class yesterday, but for whatever reason, if you didn't finish, please write it down. If you finished it, don't write it down again. You've already finished it and checked it off. But if you haven't finished it, please write that down so that you can check it off. Tomorrow we have a very simple quiz. It's just on scatter plots, correlation, positive, negative, no correlation. Just being able to identify those. Just very, very basic. Okay. Any questions? All righty. Okay. Anyone still copying it? Do I need to pause? Okay. All right. So let's look at the warm up. We're on Thursday. Please mark out Friday's warm up. We're not doing Fridays. All right. The first one says, make sure that we're all there. We're looking at the warm ups. Come on, Jacqueline. Oh, not Jacqueline. Lord, because she sits there. I'm sorry. Jocelyn. She sits in the same location. You on the warm up, babe? There you go. All right. A car traveled 36 miles in 45 minutes. So 36 miles in this many minutes. Okay. The car traveled at a constant speed. So it kept the speed up. Okay. If the car continues to travel at this rate, write an equation to determine y, the total number of miles that a car will travel in X hours. Okay, so look, let's find the rate first. The rate is rise, when you're finding the slope, it's rise over run, or the y is on the top and the x is on the bottom. Okay, your y in this case is the number of miles. So your miles is going to be on the top, and the x is the hours. So when you write your rate, you put the miles on the top and the hours or the time on the absolute bottom. Okay. So we have 36 on the top, 36 miles, and 45 minutes. 45 minutes is how many hours? It's point of an hour. Does anybody know how to find that? It's 45 minutes. How many? It's gonna be. It's not a whole hour. How many minutes out of an hour would that be? What over what could you guess? 45 minutes out of how many minutes are in an hour? 60. Okay, so we're gonna find the decimal here, and that's gonna be your hours. Okay, because there's 60 minutes in an hour, and 45 of them is what we're looking at. So let's see what that decimal is, so we can convert from minutes to hours. So let's type in 45 divided by 60, and what decimal is that? 0.75. Okay, and we did that yesterday in the scatter plot. If you probably you may not remember. Okay, so we want to know how many in a whole hour. So let's divide and figure out what this decimal is. So let's do 36 divided by 0.75 hours. And how much is that? So it's going to be 48 miles per hour. Per 1 hour. So when we write our equation, this is our slope, 48. So we have y is equal to 48x. Okay. This is how we write our equation. Remember, the number that's attached to the x is the slope, and that's what we found. Ms. Reyes, again, why do we have to convert 48 minutes to hours? Because it said x hours. So that means we have to go from minutes to hours. So how do you convert from minutes to hours? If it's 45 minutes, you're going to say 45 minutes over 60 minutes, because it's 60 minutes in 1 hour. If it was 30 minutes, then you would say 30 minutes divided by 60 minutes, because to convert to hours. If it was 3 minutes, you're going to say 3 divided by 60. However many minutes there are, you're going to put it over 60, because it's 60 minutes in an hour. Any questions about that? Okay. Anybody still copying? Need me to wait? Sit up, baby. Sit up. Okay. Let's look at the second one. It says Jane is buying apps for her iPhone. She can buy 5 apps and have $3 left on her iTunes gift card. Using the same amount, she can buy 2 apps and have $9 left on her gift card. Write an equation. Write and solve an equation to find out the cost of 1 app. Okay, so this is what we're going to do. We have 2 ordered pairs here that they give us, basically. X is always going to be, your time, your number of. So our number of here is 5, and the total amount left is 3. So X is going to represent the number of apps, and Y is going to represent the money that's left, the total that's left. So our first ordered pair is 5, comma, the money is left is $3. This is my first ordered pair, X1, Y1. What's my second ordered pair if the X represents the number of apps and the Y represents the total amount that's left? Okay, what is going to 2,9? Very good. 2 apps and you got $9 left. This is my second ordered pair. So to find my rate of change so that I can write an equation, okay, to find my rate of change, I'm going to use the slope formula. That's y2 minus y1 over x2 minus x1. Remember, when you're writing an equation, you have to have m and you have to have b, okay? All right, so let's find m and then we'll find b. So in order to find the slope, we use our 2 points. What numbers do we put on the top? What minus what? 9 minus 3. Good job. And what numbers do we put on the bottom?
2 minus 5.
2 minus 5. Okay? And so what does that give us on the top?
6.
Got 6 on the top. And what does that give us on the bottom? Negative 3. Okay. So what does that give us here? What's 6 divided by negative 3? Negative 2. So you're losing $2 for every single app. Does that make sense? Okay. You're losing $2 for every single app. So every single app is costing us $2. Any questions about that? So now we're going to figure out what the starting amount is. So to find the starting amount, or your B, you're going to use, I'm going to put right here, Y equals MX plus B. And we did this back in December, January, okay? So now we're going to pick one of these points. Which point do you feel like is going to be the easiest point to use to substitute into this slope intercept form? Do you feel like the first one, 5 and 3, or 2 and 9? Doesn't matter which one, just choose one, 2 and 9. So we're going to use this. So we're going to substitute 2 for X and 9 for Y. So for Y, I'm going to put 9 because I chose this point. Is equal to a negative 2. Okay. X is going to be 2. And then I have plus B. Okay. So now to solve, I multiply this together, which gives me a negative 4 plus B. How do I get B by itself?
Add 4.
Add 4 to both sides. Good job, baby. So when I add 4 to both sides, what's 9 plus 4?
13.
13. So B is equal to 13. So you automatically have to, the starting amount is $13 on that gift card. Okay? Any questions about that? So you start off with a $13 gift card. Questions, comments, or concerns? And for every single app that you purchase, you're gonna lose how much money? $2. How do I write this? Use this information to write the equation. Y is equal to what?
Y equals negative 2. X plus 13.
Very good. Please make sure that you write this down, and I'm going to pause for the calls. All right, so remember for Thursday, there's no homework help video. You need to go back and watch the videos from the previous week. For this one right here, I'm going to do an example. I'm not going to do this problem, but I'm going to do a small example on the side here. If I'm graphing x is equal to 2, this is what this looks like. Please watch what Ms. Reyes is doing. And x is equal to 2, draw a little coordinate plane. You're going to find 2 on the x-axis. 1, 2 on the x-axis. And you're going to draw a line through the 2 on the x-axis. This is how you graph x is equal to 2. So whatever the number is, x is equal to 7, x is equal to negative 3, find that number on the x-axis and draw a line straight through it. So these lines should be vertical. These lines have undefined slope. So this line is also going to be vertical. It's going to go up and down. And it's going to also have an undefined slope. Any questions, comments, or concerns? For number 2, you're going to use distributive property first. You distribute on both sides, distributive property. You're going to use distributive property first.
Which one is that? Monday?
Huh?
Oh.
For Monday, I already made homework help videos, okay, for the rest of the week. This is the only day I didn't. So distributive property, you're going to combine like terms on each side separately. There are probably no terms to combine here. You're going to move variables to the same side. Okay, 1, 2, 3. And then you're going to isolate the variable by using inverse operations. So you add or subtract first, and then multiply, divide should be last. Add and subtract. Add or subtract. That goes first. And then lastly is multiply, divide. Okay. And you use these same steps for these two problems here. Construct the scatter plot just like we did yesterday. All you're doing is graphing these ordered pairs. So you go over 1 and up 20, over 2 and up to 40, over 3 and up to 50, so on and so forth. All you're doing is graphing the ordered pairs. Any questions, comments, or concerns? All right, let's put this in a safe place in our folder, please. And let's take out this scatter plot booklet. Miss Moore, you already checked the homework, didn't you?
Yeah.
Thank you. So good. Okay. All right. So we already started this part yesterday. And I'm going to say this again to you so you'll know, because tomorrow you need to know how to do this part, okay? The graphing. A scatter plot is a graph with ordered pairs or points, okay, that show a relationship. The relationship is between two data sets. What two data sets? Whatever you graph along the x-axis and then whatever you graph along the y-axis. Please listen so that you're not confused, okay? I could graph age along the x-axis because you always graph time, Ramir. Graph time along the x-axis, okay? And then total along the y. So I might graph age here and height here. So I'm comparing age to height. So my ordered pairs are going to look like this. Younger people tend to be shorter. So the points are going to, as you get older, you get taller on an average. So that means my points should go up. It's not going to be a perfectly straight line because we're all different heights. So that's an example of a true scatter plot. But it has a positive correlation because as age increases, so does your height increase. Okay? All right. So that's a positive relationship. An example of a negative relationship could be the miles that you travel in your car and along the y-axis, the total amount of gas that's in your car. Gallons of gas. All right. Both are numbers. Both are represented by numbers. That's why you can put it as a scatter plot. It can't be a category, obviously, because then it wouldn't be a number. If it's not a number, you can't graph it. So you have the miles along the bottom and you have the gallons of gas along the side. So as the miles that you travel increase, the less gas that you're going to have in your car. Okay, so that's an example of a negative correlation because as X increases, Y is decreasing, so your points are going down. And everybody's car is different, obviously, so it's not going to be a perfectly straight line. Sit up, sit up, babe. All right, an example of a no correlation where the two X and Y variables are unrelated could be your weight and your grade in the class. Your weight is a number. Your grade in the class is also a number. As the weight increases or as a person's weight is higher, okay, there does not affect whatever your grade is in a class. That's no correlation because the two variables are unrelated. Your weight doesn't have anything to do with what grade you make. So that's an example of a no correlation. Any questions about that? All right, so the example that we have down here is the hours that a person studied, and hours is along the x-axis, and their score that they make on a test. Okay? And this is not, remember, look, it's still a scatter plot because just because you study doesn't mean you're going to get a wonderful grade. But on an average, most people that study longer or put more into it, they perform better. Okay? Of course, it's not always the case, but for the most part, it's true. So that's why you have a scatter plot where the points are going up for the most part. You might have some outliers. Somebody put a lot of studying in, but they didn't do too well, maybe because they're not a good test taker or they have test anxiety. So you do have an outlier or two, okay? But for the most part, the more time you practice, the better your score is going to be. So this is another example of a positive correlation. Any questions about how to create or how to graph an ordered pair like we did on yesterday? Okay. All right. Then we talk about the association, and I already kind of discussed this. The association of a scatter plot or the correlation of a scatter plot, okay, tells the relationship between what you graph on the x-axis and what you graph on the y-axis, the two variables. As x increases, y increases, that's a positive correlation. This is what the points look like for a positive correlation. The points are going up. For a negative correlation, x always increases because you always read a graph from left to right. If the points are going down, that's a negative correlation. And a no correlation is when your points are all over the place. That means that your x and your y, whatever you're graphing, are unrelated to each other. Like the example that I gave you. Your weight and your grade in the class. They don't have anything to do with each other. Any questions, comments, or concerns? All right, so now we're going to talk about cluster and outlier. And I kind of said cluster, outlier a few minutes ago. A cluster is a set of closely grouped data. That's when the points are close together, okay? And can be around a point or a line, okay? An outlier is a data point that is very different. This means it's not going to be clustered with the other points. It's very different from the rest of the data set. Okay? Breaks the mold. It's just different. It's not clustered with the other points. All right, let's describe any clusters, okay? So in this graph right here, the first thing that we do when we read a graph, and we talked about this in the little project that we had on Monday, you read the graph. The name of this graph is basketball shooting. That tells you a lot about what is being graphed here, okay? Basketball shooting. The next thing you do is you read the x-axis and the y-axis. The x-axis is the shots attempt, okay? The shots that were attempted and the shots that were made along the y-axis. We notice that the x-axis, even though every other line has a number and it's 10, 20, 30, but halfway between 0 and 10 is 5. So really the x-axis is going up by 5. This is 5. This line is 5 all the way up. Then 10, then 15, 20, 25, 30, 35. That's what you have to make sure you understand when reading a graph. Even though every other line has a number, just to conserve space, the x-axis is actually going up by 5s. The same with the y-axis. The y-axis is actually going up by 5s also. Okay, so now describe any cluster. Okay, there's a cluster here. These points are close together, very, very close together. And there's a cluster here. So there are two clusters in this scatter plot. There are two clusters in this scatter plot. Are there any outliers in this scatter plot? Are there any outliers in this, in this scatter plot? There's one outlier. This one little point up, this one lonely little point up here is an outlier. So we're going to estimate what that outlier is. It says identify it, so we need to write the ordered pair. So the ordered pair, 5, 10, 15, 20, 25, 30. 35 is the X. And then we're going up 5, 10, 15, 20, 25. And this is 25, and it's between 30 and 25, but it's really close to 30. So we can say it's about 38, 39. 28. I'm tripping. somewhere in there, 28, 29. Any questions about how to identify a cluster, the ordered pairs that are close together, and how to identify outlier, the ordered pair or two that's far away from all the other points? Any questions about positive, negative, no correlation? All right. Let's look at the next page. Was anybody still copying that? All right. Let's look at the very last page. All right, a trend line or a line of best fit or a linear model, all of those mean the same thing. And I need to write that down. So we got line of best fit, linear model, and trend line. They all mean the exact same thing. Please write those down. They all have, sometimes you'll see trend line, sometimes you'll see line of best fit or line of fit. Sometimes they'll say linear model. They could use any of these three terms. Kylie, did you write this down, babe? These are all synonyms. They all mean the same thing. All right, a trend line or a line of best fit or a linear model is a straight line. It's a straight line that comes close as possible to the points that are on the scatter plot. It's the straight line that best describes the scatter plot. Okay, this is the line that best describes. It should be a line that's in the center of the scatter plot. Should be a line that's in the center of the scatter plot. It should be going in the same direction as the scatter plot. Let me write on the back of this one. Okay. There are approximately the same number of points above the line as below. So almost the same amount of numbers, the same amount of points that's above the line is also below the line, okay? And when you're making your line of best fits, just ignore the outlier. Because it's an outlier, you're not going to include this in your line of best fit. Because it could just throw the whole line off. You're looking at the majority of the points. Where are the majority of the points? That's what you're looking for. You might have to exclude the outlier. Okay, before we use this graph as the example, I'm going to write on the back of this piece of paper to show you some examples real quickly. And then maybe this example will make more sense. Anybody still copying the top part? Okay. All right, so let's look at this. You don't have to write this. All I want you to do is just watch. You have some points that are going up. Okay. You are to choose a line that goes through the center of the data. Okay. So your line, you would pick 2 points that's kind of in the center. This point is kind of in the center, and this point might be in the center. So I'm going to choose those 2 points and draw a line through those points. Okay. So we have couple points that are on the line, 3. We have 2 below the line, possibly 3. This might be a little outlier. And we have 2 above the line. So this is a good line of best fit because we have a couple points that are on the line. We have 2 that are above the line. And we have 2 to 3 points that are below the line. So this is a good line of best fit. This is not a good line of best fit. Okay. Let me draw another. if you draw a line here, this is not a good line of best fit. Why is this not a good line? This is a good line, but this is not a good line. Why is this not a good line of best fit? Okay, very good. Most of the points are above it. There are no points below it. This line is not in the center. It should be in the center like this is, where there are a few under and a few above, almost the same amount above as below. So this is not a good line of best fit. What about this one? Is this a good line of best fit? Is that a good line of best fit? No. Why?
Because it's not above it.
Very good. This line is not in the center. There are no points that are above it. Okay, all the points are up under it. The line should be in the center of the data and not on top of it or below it. Please, Chloe, sit up. Thank you, ma'am. Thank you. Any questions about this? All right, so let's look at the example that they give us in the foldable. All right, so here, the first thing that we want to do, and I'll get back to what they say, making a prediction. I want to draw a line of best fit first. We're drawing our trend line or our line of best fit or our linear model. Those are the same word. They mean the same thing. In order to draw a line of best fit, we're going to pick, like I did in the first example, 2 good points. Okay, I'm going to pick 2 good points that are in the center of these points here. Okay, I'm going to pick 2 good points that are in the center here. Okay, so maybe I'm going to choose this point right here is kind of in the center. Okay, and maybe this point is kind of in the center. These 2 points might be in the center. Let's try it to see. Okay. Okay. This is saying you got 1, 2, 3 points that's above, and 1, 2 points, really 3 points that's below, because this is just below it, and 2 points that are on the line. That's an okay line of best fit. Okay, so we're gonna draw a line through this point right here, and we're gonna draw a line through this point right here. So now we need to estimate what those 2 points are so that we can write the equation for that line. Okay, so we're going to estimate what these 2 points are. Any questions about why this is a good line of best fit? Okay, all right. So let's write an equation for this line of best fit. So this is the point that we use, and this is the point that we use. So in order to write an equation, you have to find the slope. So you're going to write those 2 ordered pairs, okay? This ordered pair right here, we went over, this is 2, and then we went up here. This is 200, so it's a little above 200, and it's between 200 and 300, okay? So this point right here is closer to 200 than 300, and it's not in the middle, which would be 250, so maybe it's 220 or some change, 220, 210. So we're going to put 2 and 220. And it's okay. We estimated there. This is our first point, X1, Y1. Our second ordered pair we chose is right here, okay? So we went over 1, 2, 3, 4. This is 5. And we're going up 1, 2, 100, 200, 300, 400. This is 500. And it looks like it's in the middle between 500 and 600, but it could be slightly a little lower. So a little lower than 550, so maybe 540, okay? So this is going to be 5 and 540. This is our second point. Any questions about how I chose those 2 points? All right, so now I have to calculate the slope. What formula do I use to find the slope? Very good. Y2 minus Y1 over X2 minus X1. Jaden, make sure that you're listening. Poor fella. All right, what numbers do we put on the top? What minus what?
540 minus 220.
Very good, sweetheart. What numbers do we put on the bottom?
5 minus 2.
5 minus 2. Good job. All right, so let's use our calculator if you cannot do that in your mind. And let's subtract 540 minus 220. What does that give you?
320.
Very good. And then on the bottom, 5 minus 2 is what? 3. So now let's divide to see what this is going to be. See what M is going to be. We got 320 divided by 3. And what does that give you? $320 divided by 3. 106. Okay. And this is the cost of repairs, so we can do money. So that would mean we need 2 spaces behind the decimal. So 2 spaces behind the decimal would be 6. 6. Is this 6 going to go up 1 or stay at 6 if we're rounding? Go up 1. So this is $106.67. That's okay, baby. All right. And that's how much it's going to cost every year. Okay. Age of the car and cost of repairs. So each year it's going up $106 and $106.67 per year. Each year the car ages. This is my slope. So now we need, the second step is to find the Y-intercept. We did this in the warm-up. How do we find B, which is our Y-intercept? What do we use? Yes. Very good, baby. Y equals mx plus b. Excellent job. So now we're going to pick one of these 2 points. Which point do you feel like is going to be the easiest point to use, the first one or the second one? First one. I think it's smaller. Let's use the first one. So let's plug this in along with the slope, okay, to find B. So here our Y is 220. Our M is $106.67. Our X is 2. And then we got plus B. So now we're solving for B. So we have to multiply these 2 numbers together. So let's type this in our calculator. We're going to go ahead and bring this down. So let's type in $106.67 times 2. $106.67 times 2. How much is that? How much is that? $213.34. Now how do we get B by itself? What do we do to get B by itself?
Subtract 213.34% from both sides.
Very good. We're subtracting it on both sides. $213.34 on both sides. So let's type in $220 minus $213.34. $220 minus $213.34. And how much money is that?
$6.66.
Very good. $6.66. Oops. I put 66. $6.66. This is my B. So I have my M and I have my B. So how do I write that as an equation? Y is equal to, remember we're writing in Y equals mx plus b. What did we say our M was?
106.67.
Very good. $106.67. Mm-hmm.
6.66.
Very good. $6.60. This is my equation. Now, if I want to, this is my equation. So I'm gonna use this equation to figure out how much do I have to, how much is it gonna cost for repairs in 8 years? Am I gonna substitute 8 years for Y or 8 years for X?
No. Wait. So what was the question again?
Okay, so look, the X is the age of the car. Your Y is the total cost of the repairs. So here, Y is the total cost of the repairs, right? And X is the, what I say, age of the car, the years of the car. So if I'm trying to figure out how much it's going to cost for 8 years, an 8-year-old car, am I going to substitute 8 years for Y or 8 years for X?
Y, right? No, X.
X, because X represents the years. So up here, I'm going to say Y. The total amount is going to be $106.67 times 8 years plus $6.66. And let's type this in to see what we get for 8 years. $106.67 times 8 years plus $6.66. Type that in and see what total amount you're going to get for repairs after 8 years.
$860.02.
Okay. $860.02 after 8 years. That's going to be the total. We're going to paste this in our notebook. One person from each row, please come pick up a pair of not scissors, but a glue stick for everybody at your row, please. And we're going to paste this in our notebook. Anybody still copying this before I move it?
Yeah.
Okay. Do you need to see the bottom?
Yeah.
I'm going to pause for the calls here. Please don't glue it down until I tell you what page to put it on. All right, so look, this is where I want you to glue this down. Please pay attention. Okay, so don't forget to the comparing functions cut and paste activity. That was page 9. Okay, so you need to take that out of your folder and paste that down. I'm gonna pause for the call so you can find it. This is page 9. I'm gonna paste it down. Baby, I'm getting there. Please don't rush me because you know they're not gonna understand if I do that.
No, that's not gonna
Why don't she say page 9?
This is page 9. Okay. Okay, so that was 9. This is page 10. Page 10, y'all. Write this down. Q3, page 10. That's okay. This is the graphing stories. Graphing stories project. This right here, this is what you're pasting down on page 10.
Wait, they say page though.
No, it's not.
No. I'm talking about this. Never mind. I was talking about.
That's okay, honey.
No, I was talking about the. What's it called?
I know which one.
That's page 11?
It's not. No.
Huh?
That's why I said, yo, can you just do what I asked you to do? This is page 10 right here, graphing stories. Page 11 is going to be the little half slip that I just gave you. This is the introduction to cluster 5.
I didn't get one.
It's all right there.
Oh.
All right, Q3, page 11. This is intro to cluster 5. Okay, and then the last one is going to be the scatter plots. Page 12. Bless you. Q3, page 12, scatter plot foldable. Make sure you put your calculators back. And this is the scatter plot foldable.
Please.
All right, you can hand me the glue stick on the way out the door.